We have 8 vocabulary words for our plate tectonic section. Our first 2 vocabulary words describe the theories which support the movement of Earth's plates, the continental drift theory and the plate tectonic theory. The continental drift theory was developed by Alfred Wegener in 1912. And his theory was the continents were all combined into a giant single land mass about 350 million years ago, and they continue to move away from each other today about 2 inches per year. Some of the evidence that he used to claim this theory was that a lot of animal species were located now today on different continents. And these animals back in the day, these species could not swim. So that means that these animals were all combined onto a single landmass. And as these continents split apart, these animals were isolated and remained on these continents as the oceans separated them, and that's why these animals are on different continents today, because they all started on this single piece of land. Another piece of evidence is the fact that when it was really cold in an ice age, a glacier started down here in the South Pole, and it picked up rocks from down here, and it took those rocks and deposited them here in Africa, deposited them here in Asia, and deposited here in Australia. So the same rocks that were generated right here were moved from this area here of the Earth out to these different continents. So now as these continents separated, we know we've got these rocks from the South Pole on these different continents, which only means that these land masses would have been combined into a single landmass for this to have occurred successfully. Per Alfred Wegener's theory in 1912, he assumed that all the continents were combined into a single landmass. We got North America, Asia here, South America, Africa, Antarctica, and Australia all combined into one landmass. So what that means is animals like migrated throughout this landmass here, and as these continents separated, these animals were located on these continents as they separated out to where they are today. And what happens today now, all these continents continue to move about 2 inches a year. So Africa, Australia, North America, South America all continue to move today. So the continental drift theory was developed by Alfred Wegener in 1912, and that was the basis for the plate tectonic theory, which was developed in the 1960s. And the plate tectonic theory used the continental drift theory as its basis and proved many of its concepts to be true based upon geological evidence using constructions of the Earth's mantle, convection currents, lithosphere, and asthenosphere, which we'll talk about a little bit later in this presentation. The plate tectonic theory assumes that the Earth has seven major plates, and then it's also got some minor ones here that it leverages. And what happens is as these plates combine, and move away from each other, what that does, that creates earthquakes, volcanoes, trenches, new crust on the Earth. So that's essentially what the plate tectonic theory does. It basically proves the fact that Alfred Wegener's theory was actually true. So in the plate tectonic theory, tectonic means building or construction. So the plate tectonic theory means building by using plates. So, like as I noted in the last slide, Earth has about 7 major plates and about eight or more minor ones. And these plates keep moving towards each other, like for convergent theory, or away from each other, like this, in divergent theory, or transform theory, which is like in the San Andreas Fault by Los Angeles and San Francisco, which causes earthquakes. What we've got is a couple of different items. We've got the lithosphere here, where these plates sit on top of this hard crust right here, and the plates right here, the 7 major plates, move on this lithosphere. And what causes those plates to move are these convection currents right here, where you've got the heat of the core of the Earth, which is about 9,000 degrees right here, which is about the temperature of the sun. So it heats up this molten rock, which is iron and nickel. It heats us up. It goes up here. It cools down and comes right back down here. This is a cyclical process right here, where this moves. And it moves these convection currents, which moves this lithosphere, which allows these plates to move and create these boundaries, this convergence, divergence, and transform, which we'll talk about in a little bit. But these convection currents are cyclical and they're constantly happening. So convection currents happen in both the air when it's moving hot air, cold air, in the air pressure system, the tropical area, ocean currents, and it also happens in the mantle, which is the liquid rock, which is iron and nickel moving around, which allows our plates to move and our continents to move about 2 inches per year. So there are two key points here. As I noted in the previous slide, you get the lithosphere here, which is like the hard crust, where those plate, like the ocean plate here sits on this, and you've got here the crustal plate here. Well, these two plates combine, they merge into each other. This ocean plate will end up sinking here and probably cause a trench right here, or possibly volcanoes right here. And then in addition, you've got the asthenosphere, which is right below here, which is kind of like the molten nickel and iron, which is it's kind of like lava. So when these two plates migrate this way, and then new crust comes up here and forms right here, which creates some new crust in the divergent theory. So because of the convection current in the asthenosphere, where that cyclical process, what that does, it also moves lithosphere and those plates on top of the crust. And our plates they move in three different ways. They converge towards each other here, or they'll drift apart this way, and then they'll transform, which means they slide past each other. So for the convergent theory here, lots of times this will cause those plates to mash into each other, create mountains and volcanoes. Whereas if they drift apart, that can create volcanoes or create just trenches, and it also creates new crust. If the plates are moving away from each other this way here, that allows new crust to be reformed right here from the asthenosphere. All that lava, all that nickel and iron comes right up through here and creates new crust as these plates move away from each other. And down here for the transform theory, this is where Los Angeles and San Francisco are important, because what that typically does when they move away from each other, they hook on each other a lot of times, and most often they cause earthquakes. And that's why you see lots of earthquakes in Los Angeles and San Francisco. So we'll talk about each of these movements specifically. For the convergent theory, which means two earth plates are moving towards each other. So when those masses meet, that mass has got to go someplace. Either it's got to go up or down. When it goes up, it creates mountains like the Himalaya mountains. That's when two plates are moving against each other. That mass has got to go up like this right here. That's when it goes up. Another instance is where it goes down, where the oceanic crust is more dense than the continental crust. So what happens is that oceanic crust comes down here and gets subducted underneath here, which creates a trench in the ocean, and it also creates a volcanic arc, because what happens, it does that and allows the asthenosphere, this molten rock, to come up here and cause volcanoes. So see all the volcanoes here where these plates are converging against each other here in the world. So for the convergent theory, you'll see lots of mountain ranges. When that mass goes up, you'll see some trenches and volcanic arcs along the coastlines where the coastal and oceanic crust plates meet. The primary component of the divergent theory is this means that the two plates are moving away from each other. And the key thing I like to recognize here is the fact that when these plates move away from each other, it creates this trench right here, or this ridge right here. And what happens is that it can open up a section for the asthenosphere for raw iron and nickel to come up here and create this new layer of crust between these two plates. So that's the main thing about divergent theories I like to keep up. It creates this trench or this East African rift, which happens in Africa, and also it creates new crust. These are the top two things that I'd like to keep in mind for the divergent theory. The transform movement, the core thing I like to keep in mind, is it causes earthquakes, because what's happening is you've got two plates moving, one moving this way and one moving this way. And what's happening, the earth is getting stuck right here in place and things like that. And every now and then it'll hold on. Then sometimes what will happen is this will release very fast. It's released very fast, and this will cause all these things to become undone. and it'll cause a large earthquake, which will be a large earthquake. And you'll see that right over here. Here's San Francisco and Los Angeles, right in here, the San Andreas Fault right here. But it caused look what earthquakes are happening all around the world because of what's happening here on these divergent planes right here. Right here, if it's in the middle of the ocean, it causes tsunami. But as things are moving away from each other, this causes earthquakes. So the transformation, earthquakes, and think about Los Angeles and San Francisco as a primary example. And here's one interesting deal where you've got this line. You see how these two plates move across from each other. Look at this stream coming right here. But over time, look how far it's moved this way, because you can tell the Earth. Here's the San Andreas Fault right here, where it's moving this way. So you can see where this is right here compared to where it should be right here. This is the San Andreas Fault in California. So earthquakes is the main thing to remember about transformation movement.